So today, what is our objective? Today we're going to work on understanding functions. Because I've been using that word, but I want to make sure that you understand what it means fully. We're going to talk about representing functions. With equations. And you're going to realize you kind of already know this. There's just going to be a teeny little change to it. And we're going to talk about equality of functions. So this comes with 3 little parts, and again, most of it you've already seen, but now we're just going to cage it in a different way. So this comes out of the online book. Oops, maybe if I could spell book. This is the Module 5, Lesson 5.2, and just to let you know, there's a personal math trainer for each of the sections attached to the Your Turns on page 126. That's going to go with understanding functions. On page 127 for the representing functions with equations. And then on page 129, to go with the equality of functions. Okay, so each one of these objectives has a personal math trainer that you can check out with it. All right? All right, so let's go back to definition of a function. Function. What is a function? Okay, so a function is a set of ordered pairs. That's not it. That's the beginning of it. Set of ordered pairs where each domain value, which one is the domain? The x value. Has exactly one and only one, has exactly one value in the range. And the range value represents what? The y value. Okay, so I'm giving you a textbook definition, and now I'm going to give you, okay, so let's make sure that we understand what this means. When I plug in my x value, I only get one y value. So that y value is only attached to exactly one x value. Okay? Each x, and I'm going to write it this way, has a unique y value. Okay? So I'm going to kind of present this information 3 different ways. Let's again make sure we've got domain, x value, range, y value. Okay. So there's a scenario that they give us in the book, and it talks about a fundraising program awards $30 for first place, $20 for second place, $10 for third place, and $5 for fourth place. This function can be written as ordered pairs. 1, 30, 2, 20, 3, 10, 4, 5. Okay? Notice that the position you're in gets a unique payout. Okay? Nobody gets the same payout according to the way that this program worked. So I'm going to just recap that briefly. So we've got let's see what they call it, fundraising. So kind of like a magazine drive. So the fundraiser prizes, first place, you're going to get a $30 award. Second place, you're going to get a $20 award. Third place, you're going to get a $10 award. Fourth place, you're going to get a $5 award. Notice there's nothing for anyone in fifth place or less than that. Okay, so we're going to write this. We're going to express as a table, which you guys should be used to seeing. We're going to express it as a graph, and we're going to express it as, this is a new one perhaps, a mapping diagram. Okay. And let's see, what else do I want to put in? Oh, remember what they said to us as well, is that we could take these first place through fourth place with the awards and write them as an ordered pair. So when we come in first place, you get $30 award. If you come in second place, you get a $20 award. When you come in third place, you get a $10 award. And when you get fourth place, you get a $5 award. So that's going to help me set up my table. So my table, that strategy, we would have ranking, and we would have prize. And I'm going to put a $sign after it to let you know how we're labeling our answer. So if we rank first, we get $30. We rank second, we get $20. We rank third, we get $10. We rank fourth, we get $5. Pretty easy. So if they asked you to express as a table, that's all you would do. Okay, you have to title your tables. Okay, like even what we've been doing last few days, X, the equation, Y, and the ordered pair, same idea, we got to label it. All right, so now we're going to take that, and now we're going to graph it. Okay, and I could do it in a coordinate system, or I could kind of consolidate down my coordinate system to the portion that I'm going to actually graph in. So of the 4 quadrants, what quadrant am I going to graph all these points in? First quadrant, right? So that's where I'm going to kind of consolidate my graph. So this is your x-axis, this is your y-axis. Now when we're doing a graph, we'd still want to put that in. So what's interesting about this one is that the intervals are going to be different based on the numbers that we're going to use. So ranking is going to go on the bottom. And then we're going to have dollars on the side. So I'm going to tilt mine and write sideways, dollars. That looks like dollars. I will correct that D. Okay, so I need to go up to 4 on ranking, and I need to go 10, 15, 20, 25, 30. I'm going to go a little higher on this guy. So here's 10. Here's 20, here's 30. So I chose to count by 5s. I could have chosen to count by less than that as well. So when it asked me to plot, it didn't ask me to connect. It just asked me to plot. So, oh, I forgot to put numbers down here. 1, 2, 3, 4. So first place got me $30. Second place got me $20. Yep. Third place got me $10. And fourth place got me $5. And that's all I would do. On this particular one, I would not connect them up. Okay. And what you might notice is that what was the difference between first and second place? $10. And between second and third? And between third and fourth? 5. So there's not a consistency between those differences. So honestly, we would not get a line for this particular drawing. Okay, it'd be slightly curving at the bottom. So then the last one says mapping. So mapping looks like the table, except we're going to separate things. So with the mapping, we have ranking. And under ranking, we have a box that contains my ranks. Then I have another prize label with dollar signs, and I get another box. And 30, 20, 10, 5. And what I do is I draw a connector from the ranking to its prize. This particular way that I drew it, they are directly across from each other. What makes me visually understand I have a function is that each x only went to one y. If an x branches out to two different y's, it's not a function. It's called just a relation. They put these ordered pairs together for some reason, but it's not a function. I cannot predict what's going to be happening next. Okay? So those are the three categories. All right? So that is the first objective. Any questions? So understanding functions. Again, we're going to get into it more with equations, which makes more sense to us because that's what we're dealing with. Okay? And it deals more with that idea of, for us in our minds, a function is like a rule. It's an equation. We can plug numbers in, we get numbers out, we create our pairs. Ethan?
So if there was another 30 in the prizes, then it would be a function?
Yeah, let's say first place and second place got $30. It wouldn't be a function because then we would have two things that are going to the same value. So it has to be unique. Or you could say, no, it would be more like if first place, you could get $30, or you could take this gift card for $35, but that $35 gift card may be someplace you don't want to go, so you would take the $30 cash. So the problem is I have two possibles for first choice. That's no longer a function. Okay? All right, so let's talk about representing functions as equations, because that's really what we're doing it. So here's what we've been talking about when it comes to functions. We've written the equation two different ways. We haven't named this way yet. We will. By the way, there'll be probably a quiz. There may be a small one on Friday, but there'll be a bigger one next Wednesday, and that will before break. We're not going to get done with this whole unit of study. Mr. J and I were sitting down. This unit of study is huge, so we're going to be on it for several weeks. But we will take it before we go on break. And our plan right now is to let you guys kind of hang out with Gigi on Friday. So that way you can play with Gigi at home. Because once you get signed on at school, then you're free to play at home. Okay? All right, so we're used to seeing this. We have an equation, two variables, y equals 2x plus 8. So how do I rewrite this as a function? Okay? Well, what I'm going to do is say, keep this in mind. This value is your input. And based on that value x, so this is the x we're talking about. Let me circle him up. The x is your input value. Based on the x you put in, you get a particular output. So the output is directly related to the input. So what we say is the output is a function of the input. So let me tell you what function notation looks like. Function notation says, here's your function. The variable that we're putting, using as our input in this particular function is called x. Okay? So they would take that equation and now they'd say it's this. The function f in terms of the variable x is 2x plus 8. So they're telling me this is a function. We've named it f for whatever reason we want. And the variable has to match the variable of your equation. Okay? Now, What are the typical function names? I don't know why. I mean, f I do because it's function, but they also have g, whatever the variable is, and h. Seem to be the three most famous ones. Why? I don't know. I think just because they come one after each other. But those are the function names that you're going to see most often. Okay? So what we're going to do is we can use this anytime we have a function. We can use that function notation. If it's not a function, if I can get two answers, when I plug in x, I can get two answers, then, and it's not a function, then that's when we are going to go ahead and say, okay, I can't use that function notation in the front. But all the equations we've been dealing with so far, trying to think of everyone we've covered. Yes, we could use that function, okay? So, here's what you're going to get. If they give you a function, you can solve it just like you would the other guys. Oh, let me write one more thing. When you're reading this, you can say, it's read a couple of different ways. It's read often as f of x. So this is the function's name. And this is the variable the function's written in. And remember, function is just a fancy way of saying rule. Okay? So f of x is what you're going to hear people say. Okay, so let's say they gave us a scenario in our book that Julio, the number of dollars he works per hour can be represented by a particular function. So let's write this. Julio the number of dollars earned for working X hours is represented by the function f of x equals 9x. So let's talk about this logically. What would the 9 represent in this particular situation where this function represents how much money he's going to make after working X hours? So what does the 9 mean? So dimensional analysis. X is the number of hours. The function is supposed to relate to the number of dollars. So what does the 9 represent? Look. The amount of money he makes in an hour. So what we're having is $9 per hour. That's how we can use dimensional analysis to figure out what something is. Well, it's got to be something, it's got to be money per hour, because we want the hours to cancel with the hours and leave you with the answer of money. So that's his hourly rate, what we call it. So $9 is his hourly rate. Okay. So if somebody said make a table of values, then you're going to do the same thing we've been doing. We're going to pick an x. We're going to plug it into the function. And then we're going to have the answer to that function. And we're going to look at it as an ordered pair. So notice that the y and the f of x are interchangeable with each other. Okay? So if he doesn't work at all, guess how much money he makes? He gets nothing. Poor guy. If he works 1 hour, how much money does he make? He makes $9. So 1 hour, $9. If he works 2 hours, he's going to make $18. So what is not changing throughout this entire work schedule this guy's got? What's staying the same the whole entire time, Brian? Yeah, again, the more he works, then it's not the more money he makes per hour. He just has more hours he's working, okay? So his rate of pay does not change. His rate stays the same. If he works 3 hours. Oops. How much money is he up to now? $27. Okay? So with a function, there's a predictability to what's going to happen. The numbers that are given to us in the function stay the same. So in this particular case, his rate of earning stays the same. So again, big idea here for our purposes, y is the same as writing a function f of x. Okay? All right. So then what we could do is we could look at graphing this. Okay, I'm not going to graph it because it's a lot of big numbers. I guess I could count by bigger numbers. Because again, we could do the graphing. And here's the thing I want to take from this. If I asked you to list just domain numbers, what would be considered the domain numbers in this problem? Yeah. It would be all the guys in the X column. So my domain, we would pull from here. And we would list it in what they call solution set notation. So those are those braces. And we just simply list. Okay. If I ask for the range, we're now listing what we got when we solved the function. So we get 0, 9, 18, 27. Do we have to write them in a certain order? The answer is actually no. We just need to make sure everything in the domain column gets included. And then for the range, everything in the range column, which is the function column, gets included. Okay? So the order doesn't matter. All right? That might be a possibility now that you understand that if we have a map of information, the way that they're drawing it, they're putting it in order. What's here goes directly linked to here. Or if it's out, they're going to draw you an arrow. So now you come up with ordered pairs that you can graph. So yeah, this would be real simple to go from here to graphing. Okay? Yeah.
If you want to graph this, would you count by 5?
I would, you were going to have different intervals because of what we're going to just focus in on that positive or quadrant 1. So you would have, I would say in this one, I would be counting by ones obviously for the domain because they're small. But with the, I think the logical way to count on the range would be by 3s. Okay, because all those numbers have a multiple of 3 in common, so that might not be a bad way to go on that one, is to count by 3s. And I think the book might have counted by, oh, they counted, yeah, they counted by 3s. Okay. All right, so let's see. Let's talk about equality now. So equality says sometimes you can take two different functions and they may not have the same letter, but they may tell you that they have some points they have in common. Okay, so let's go through an example of what I'm talking about. Given the functions f of x equals 3x plus 2 and g of x equals negative x plus 10. Okay. Okay, so we have these two functions, and what we want to do is find the value for x. Which gives us the two functions equal to each other. Okay. So we have a couple ways to do this. Number one, we can use calculations, and we can set the function rules equal to each other. So we would take 3x plus 2, that's the f of x, equals negative x plus 10, that's the g of x, and then we would do opposite operations to get the x's on the left and constants on the right, and then we would get 4x equals 8, divide both sides by 4, and we would get x equals 2. So we would conclude that the function of x is equal to the function of, g of x when x equals 2. So that's one way to solve it. Another method is to create tables. Of the functions. And look for a common ordered pair. Okay. And we would be looking specifically at the domain or x value. Would be our answer. Now the problem with this is, what if you don't pick the right x? That's where we could come into problems. So you are going to be looking for positives. So, and again, if your answer is not an integer, it may not be in here. So this is not usually the best way to do this, but again, I'm just going to demonstrate it. So we've got our first function, f of x equals 3x plus 2. Oops. And we're going to get out our y value, which is our f of x value, and then we would get the ordered pair. So try 0, and we get the function of x is equal to 3 times 1 plus 2, which is 3 plus 2, which equals 5. And what we could do is simultaneously do this for the other function as well. So let's shorten this guy up a little bit. And let's put the other table underneath him. So again, that function is also in x, but the function for g of x is negative x plus 10. So when you plug in 0 for that one, you get negative 0 plus 10 equals 10. So definitely, that's not our solution. So let's try 1 for each one of them. Oh, actually, let me change one thing. What we can do is write that we're figuring out the function at 0 here. We're going to figure out the function at 1. So we get 3, oops, hello, maybe if my brain would work. Let's go back and solve this one again. So we get that plus 0. So we get 0 plus 2, and we get 2, and we get 0, 2. So again, 0, 2 and 0, 10 don't match. And same thing here. Let's change this color. So now we're going to plug in 1. So we already did this one. Is 3 plus 2, which is 5, so we get 1, 5. So let's see what we get down here when we plug in 1. And that's going to equal negative 1 plus 10, which is going to give us 9. Oops, let's change that color. And that's not a match. Alright, so let's try 2. So when we plug in 2 into the function, we have 3 times 2 plus 2 gives me 6 plus 2 equals 8. And so let's try 2 on this one. And the function g at 2 is equal to the negative of 2 plus 10 equals 8. And what you notice, we finally have a match. So we can conclude that f at x is equal to g at x when x equals 2. Okay. And then we could actually graph these equations as well. So we can take the ordered pairs that we just got from the 2 functions. So if you recall, we had points for the f of x of 0, 2. We had 1, 5. We had 2, 8. And for g of x, let's change colors on this one. Let's make f of, let's make f, let's move him. He'll be green, and then we'll make g of x blue. And the order pairs we got for that guy were 0, 10. We got 1, 9. And 2, 8. So for graphing here, let's make sure we get up 1, 2, 3. For all positive, I'm going to drop this down. And again, this is if you don't have graph paper, this is going to be really hard. So we've got 10, 8, 6, 4. Oops, counted wrong. Let's try that again. 2, 4, 6. Nope. 6, 8, 10, and we go up to 2. So for the green guy, we had 0, 2, 1, 5, and 2, 8. And if I graph that, that's what I get. And if we go for g of x, we have 0, 10. We have 1, 9. We have 2, 8. And we look for the point of intersection, which was 2, 8. So hopefully you've seen from this demonstration, it looks like method 1 is the easiest way to solve this by setting the functions equal to each other and solving. So again, we would conclude that f of x is equal to g of x when x equals 2. We get the same output on that. So again, first method, set the 2 equations together, solve it algebraically. Second, come up with a table and hope that you come up with a matching ordered pair. Third is to graph the 2 functions and then to see where they intersect. All right, good luck.